Question is, the high frequency C versus VGS characteristics of a MOSFET is shown in the figure with VDS equals to 0. The graph corresponds to. See, this is graph greater than T point is nothing but accumulation mode. Graph less than R is depletion mode. So here the channel getting depleted as VGS becoming negative means what? It is going to reject electrons in the channel for negative and attracts the holes into the channel, means it must be a p MOSFET. See here already channel is not present. With the help of the VGS potential we are getting the desired charge into the channel, means we are enhancing the channel to get the required channel for the carriage of current. So it is an enhancement type p-type MOSFET, that is option A is correct. In which of the following memories read operation is non-destructive? See, in case of SRAM, while reading the data is got retained by the cell itself, means it's not going to lose the data on reading on the performance of reading operation. But in case of DRAM, so we have to perform write back operation at the end of each read operation in order to restore the data read by the read operation. Hence the read operation in case of DRAM is destructive, whereas in case of SRAM is non-destructive. Hence option A is correct. A discrete time system has an impulse response h of n. The system is here. Statement A is stable. See, if we check the stability condition for the given h of n, the summation means it has to be absolutely summable, means the summation of h of n must be less than infinite. See, h of n is not equals to 0 for n is greater than or equal to minus 3, whereas 0 n less than minus 3. Here h of minus 3 is nothing but 0, h of minus 2 is minus 1, h of minus 1 is 0, h of 0 is 1, h of 2, h of 1 is 0, means the samples are going to be repeated in this way. 0 at the 0 instant the magnitude is going to be 1, at 1th instant the magnitude is going to be 0, 2, means if we take the absolute summation of all these samples it is going to be 0, which is a finite value. Hence it is going to be a stable. It is stable. If we check the causality condition, means in order to check the causality, the condition is h of n must be 0 for n less than or n less than 0. But it is not true, because h of n is non-zero for n less than 0 too. Hence it is non-causal system. See, if we want to check the memoryless condition, means what? The h of n has to depend only on the present value of n. But here if we take h of n is 0, we will get cos 0 u of 3, which is depends upon the future value of the input. Hence it is memory system, so it is a stable system. Hence option A is correct. Question is, integral minus 4 to 2 cos of 2 pi t del of 2t plus 1 dt. Here 2t plus 1, assume x, so 2 dt equals to dx, so dt equals to dx by 2. If t equals to minus 4, x equals to minus 8 plus 1, which is equals to minus 7. T equals to 2 means x equals to 4 plus 1, which is equals to 5. Here t equals to x minus 1 by 2. So if we substitute all these values into the equation, so we will get minus 7 to 5 cos of pi x minus 1 del of x dx, this is 1 by 2. Here this total summation equals to, suppose from the property, if it is a b sum f of x del of x dx equals to f of 0 if a less than 0 and b greater than 0. So if we use this delta function property, we will get 1 by 2 cos of pi, which is equals to minus 1 by 2, and answer B is correct. The filter corresponds to given h of n is. See, in order to check the what kind of filter it is, we need to convert h of n into the frequency domain, that is h of e power j omega equals to summation h of n e power minus j omega. Here omega is the digital frequency, that is the range of omega is minus pi to pi. So h of e power j omega equals to 5 e power 5 plus minus 4 e power minus j omega plus 3 e power minus j2 omega plus 2 e power minus j3 omega. So if we substitute omega equals to 0, then we will get as 5 minus 4 plus 3 plus 2, which is equals to 6. If we check e power at highest frequency, that is j pi, 5 plus minus 4 e power minus j pi plus 3 e power minus j2 pi plus 2 e power minus j3 pi. Here 5 e power j pi is minus 1, hence it is 5 plus 4 e power j2 pi is plus 1, this is plus 3 pi is minus 1, it is minus 2. So it is 5 plus 4 9 plus 3 12 minus 2, it is 10. So h of e power j0 is less than h of e power j pi. It means it is working as a high pass filter, hence option C is correct. If the bandwidth is the major concern, the most desirable and the least desirable choices respectively are. We know the bandwidth relationships among the given data, that is VSB, ASK, PSK, FSK. Here the bandwidth required for VSB in relation to ASK is very less. This is the relationship between the bandwidths of VSB, ASK, PSK and FSK. If bandwidth is the most desirable is VSB, least desirable is FSK. Hence option B is correct. For the counter shown in the figure, the present count is 0100. Count after 2 clock pulses will be. Here D1 equals to Q4, D2 equals to D1, that is Q1, D3 equals to Q2, D4 equals to Q3. We know that Q1, Q2, Q3, Q4 initially 0100. After giving the 1 clock pulse, Q4 is shifted to D1. It doesn't mean that it means D1 equals to Q1, we know. So this is 0 and Q1 spread to the D2, that is Q2, that is here shifted to 0, here shifted to 1, here shifted to 0. Next clock pulse, this 0 here, this 0 here, this 0 here, this 1 here. So after 2 clock pulses, the output is 001. Here option B is correct.